So welcome to this our final session today, building on edge construction in adverse technologies, adverse climatic conditions, especially in difficult terrains. In India, our infrastructure ambitions are not limited by geography, but they are defined by it. So that is what maybe we would like to look into it, right? From sub-zero oxygen depleted heights of Siachen to Daulat Beg Oldie, or maybe landslide prone areas in northeast, maybe Tawang or Kameng, right? Indian engineering fraternity has been redefining the limits and possibilities, right? So this session will be looking into these aspects of how climatic conditions can be overcome, and our construction technology has progressed very well, right? So this session is chaired by Brigadier Randeep Chauhan ji, right? CE Army Liaison. Panelists include Jermia Dykes, Design Building Shillong Smart City Limited, Mr. Deepanshu Garg, Operations Director, Gypsum Structural India Limited, Mr. Hari Kumar, Regional Coordinator South Asia, Geohazard India, Mr. Harsh Joshi, Chief Executive Officer, Prolite Autoglow Limited, and Naveen Piplani. Sorry. So up to Harsha Joshi. May I request Brigadier Randeep Chauhan ji to come onto the dais, please? यार वो लास्ट वाला फिर वही किया यार, वो नवीन पिपलानी है नहीं, इसमें बोला था ना, वो फिर उसी में डाल के लेके आए. May I request other panelists to come onto the dais, please? Jermia Dykes, Mr. Hari Kumar, Mr. Harsh Joshi, Harsha Joshi. May I request Brigadier Randeep Chauhan sir to start the session with initial remarks?
We can play the presentation.
Yeah, they will do it. You just need to press this. They might have uploaded it.
Yeah.
Presentation. Yeah. Thank you, sir.
Good afternoon, ladies and gentlemen. Today we are having this seminar, or you can say session, on the current very important topic of construction in extreme climatic condition and difficult terrain. And before we start the session, I will just give a perspective from the Leh-Ladakh region, which is when we talk about the extreme climatic condition, difficult terrain, that is the first thing which comes to all of our mind. This is the physical reality of the area, though we will be talking on different topic in the our session, but I will just give a preview about what Indian Army is facing the challenge, and we are looking for the industry to give us the solution and to help us out on this most important strategic nation building task. Ladakh region is a dream destination for holidays for all of you. We are living in and out there. There are important ridges which separates the mainland from this terrain. It's a very unique terrain, one of its kind in India, not seen anywhere. The first is the Zanskar range. From the Zanskar range, the height starts picking up, and we have the heights going up to 7,000 meters. Thereafter, the next range comes is the Ladakh range, and the Ladakh range, uh, again the heights sequentially starts going further up. Between the Zanskar and Ladakh, we are having the uh, area which is a valley in which the Leh is situated. Presently, all our infrastructure, major infrastructure is coming up in this area. After Ladakh is the Karakoram, the highest on which the K2 mountain exists, and this is the area which is next to our borders with China and with Pakistan. And there the heights goes further beyond 7,000 meters. The area which we are talking about at an average altitude of more than 3,000 meters, and the Indian Army is deployed in a heights 4 to 5,000 meters where troops are deployed and they are stationed throughout the year. The area is now, the seismic risk has jumped from zone 4 to zone 6, and this involves a lot of technical intricacies in developing the designing and the construction. These areas are very isolated, though the main road connectivity has come up till certain points, but beyond the main road, all the side roads, the connectivity is still not that good. And the rainfall is very less. The water availability is only seasonal, oblique it is from the river which is down below the valley. These are the main connecting roads and the choke points you all are aware about. There was two major axes going to Leh, one from Srinagar, Zojila connecting Kargil and there further going to Leh. Another was from Manali, Darchula and further going to Leh. The third axis has now come up, which is via Padam. So Darcha, Padam, Nimu axis, which is most probably by next year, this will also be functional. So these are the axes and the passes which are en route. Coming to the resource part, though the area is totally devoid of any local resources, stones are not present in adequate quantity, oblique in the requisite strength. The water is very minimal and local labors are very scarce. So hence it means all our construction material like cement, steel, skilled labor, everything has to be imported to that AOR. The logistic is the main issue because our working seasons are very limited and the passes get closed. Only in the limited working season we have to get our stores inducted. The area there gets frozen. Like yesterday morning when I came from Leh, the temperature was -10. When I landed here, it was I think 30. So that is the kind, and this is one of the very fair weather. When you talk about December, January, it is still colder. So that is the major constraint. The wind factor is very high. So this means the oxygen level is very low. It affects both man and material, and we have to be sensitized of this aspect. The most important aspect there is the terrain. The terrain, though by look of it, it looks like a flat area, but actually it gains lot of altitude. And so hence it's very important to do the slope stabilization, terrain alternation, like you see all the gompas which have been made there. They are the buildings standing there for hundreds and thousands of years. So similar way, the construction activity has to be very deliberate and modern execution has to follow the basics of slope stabilization. These are the things which have already been done by military engineering services. Their detailed investigation, thereafter stabilization and foundation. These are the things which have been taken up in a smaller scale, but what is the need of R is taking it to the next level. The next thing is basically the time for foundation and for construction. Hence, prefabricated structures are the main stay of what is going to happen in future. I was just interacting with one of the manufacturer of steel, and we were saying you have to come up in a big way because all big structure like hangars for aircrafts, hapters, and big storage building, they all have to be made with these prefabricated structures. We just listened to a talk about the 3D printing. We have made one of the bunkers there with a 3D, and one more small building is being made. But what is need of ours is taking it to a higher level. And whether it is successful, we are doing on experimental basis. We have made a plastic road also recently, where we have incorporated the waste plastic in the road construction. So these are the experimental things which have to be taken up. I was just interacting with one gentleman. He was mentioning about the Leh airport. In 1961, this airstrip was a temporary airstrip, and 1962 war happened. Lot of equipment and men were inducted, and the runway became totally non-functional. And gentlemen, within 5 months, the combat engineers there have constructed the cemented runway, which is existing till date. And last year, one more parallel taxiway, which is same length and same dimension, which has been constructed in record 2 years time by MES. So these are the things which are doable. It has been done in past, it has been done. Only the focus of our industry has to go towards that side. Recently, one more airfield at Neoma has been created, again within the 2 years time frame, by first stabilizing the soil and thereafter doing the cementous portion of the top. The next aspect I want to cover is the connectivity of this grid, national grid. Till 2019, there was no electricity in Leh. It was all on generators. In 2019, first time the electric grid came across from Srinagar, across Zojila to Dras, and thereafter to Leh. Now further, under the different PDSS and PD Prime Minister schemes by the electricity department, the contracts have been done, and now they are further going across to Siachen base camp this year, and it will be connected, and going to Neoma and Hanle and towards the Pangong. So because these are terms you all will be familiar with. Otherwise, these areas will be connected by electricity in next 1 or 2 years. So there is a national grid which has come up. Now then there is a issue of the solar panels. Lot of things have come up, but there is a issue of batteries. At minus 40-degree temperature, the battery life reduces almost to 50%. But what we have to look after is the passive solar strategies, because the area has intense solar radiation. We must take the renewable energy, and also the building designing has to be compact, phase changing material has to be used, and also there is a climatic change and the weather is now changing very fast. The summers are getting hotter, so natural ventilation has to be incorporated in design. Then coming to my last aspect of the sewage treatment, I was just going over a stall and checking out their biodigester. So all the things are not working, not even designed, not even thought of working at minus 40-degree. So we have to look for that, because once the bacteria dies, then there is nothing which happens. Pollution is one of the major aspect. The local population as well as this area is very eco-sensitive zone. We have to look for this pollution and environmental effects which we are doing in our construction. The digital engineering and digital twins have been talked about. I want the industry to incorporate these aspects in their designing and monitoring process. These are the kind of infrastructure which has already been created in not only Leh but in the forward areas. Now, but these have happened in small pockets. Now we are looking for a bigger area, much more bigger infrastructure projects coming up. The way forward is basically we have to have our own engineering design. It cannot be copy paste from what is happening in the plain areas. Hybrid combination of different technologies has to be done, and the research and development has to go in part of it. Gentlemen, here I come to the end, and I will be now calling the other presenters to present their topics which are not fully related to this, but they are in some other fashion. What I want from industry through the medium of this Municipalika, that they must come forward and interact in Leh. We are located, I am located in Leh we must interact and look for the future development of this area, which is very strategically important and nationally very important topic. Thank you.
Sideways.
Okay, ladies and gentlemen, we'll start the session. I will now request Mr. Harsha Joshi to give a talk on the light pollution and emergency lighting.
Good evening, everybody. Good evening. Okay, my name is Harsha Joshi. I'm the chairman and CEO of Prolite Autoglow Limited. Thank you, Brigadier Sir, for your opening particular statement, and to all the panelists sitting over here. We can design and manufacture what you want in lighting and emergency lighting. We are a company which is 42 years old, okay, doing projects worldwide, and even we are designed for Antarctica mission. We are now doing Nuclear Power Corporation, where seismic zone, you said 5 and 6. We are designing lighting up to seismic zone 10, 9, 10. We have been doing that for different nuclear power corporations. Okay, so I'm also the president of the Lighting Association of India. It's called Indian Society of Lighting Engineers. Could you restart that, please? After I finish, could you restart, please? And I've just started India's first light pollution NGO. It's called safedarkness.org. Okay, we are getting a very good response from a lot of architects and lighting designers throughout the country. Thank you very much. I'll send please start the video now. My presentation will be there on the video now. Thank you very much, sir.
All of a sudden, power blackouts can put the lives of people at great risk. An unforeseen fire can occur anytime.
And our policy has been from 1984 that whatever we don't manufacture, we don't sell.
More than 1,80,000 fires,
Volume, please.
taking the precious lives of several thousands of people year after year. The pioneer of emergency escape lighting and signages in India, with a track record of innovation spanning 4 decades, is Prolite Autoglow Limited, a mission of lighting up the path for saving lives. Way back in 1984, a visionary entrepreneur, Mr. Harsha Joshi, developed an emergency light indigenously, conforming to global standards. Thus began the journey of Prolite Autoglow. Over the last 4 decades, Prolite Autoglow Limited developed many products to become the largest manufacturers of the widest range of BIS certified emergency escape lights and sign ages in India. The Prolite range has over 200 types of emergency lights, and the Autoglow sign ages has more than 20,000 types. They are installed in hotels, restaurants, hospitals, auditoriums, cinema halls, shopping malls, sports stadiums.
All the major
corporate
projects
offices,
in the country
banks,
we are doing,
IT
including the
parks,
Parliament
factories,
House, all the
warehouses,
tunnels.
airports, metro
So
stations,
we are one of the
urban
oldest
streets,
companies
and
in our
hundreds of residential buildings
worldwide
and
in the
complexes.
field of emergency
With
and
more than
escape route lighting
25
systems
million
and specialized
products
lighting.
working all over India and around the world, Prolite Autoglow has a growing global footprint. Headquartered in Mumbai, Prolite Autoglow Limited is driven by its relentless R&D efforts, introducing innovative new products in almost every 2 months. At 100 kilometers from Mumbai is the Vada Industrial Belt, where Prolite Autoglow has its manufacturing facility. This Make in India mega factory has 4 integrated production units and a dedicated R&D center for 100% in-house manufacturing. of a wide range of products. All the operations are governed by global quality management systems and processes. The products manufactured here conform to the National Building Code, National Lighting Code, and all the applicable BIS, as well as international IEC and EN standards and codes. CNC pick and place machines carry out pick and place assembly of PCBs, followed by inline oven curing. Every board undergoes testing for defect-free stability. At the automatic assembly line, expert technicians assisted by automatic tools carefully assemble multiple components into complete light assemblies. The assembled lights undergo rigorous testing cycles of 2 to 3 days so as to determine the desired life cycle and period of operation. A dedicated unit is established for assembly of large-size lights made of SS, including flame-proof enclosures and heavy-duty searchlights. Quality-tested lights are carefully packed in cartons for safe handling and transport. The auto-glow range of signages make the darkness visible by absorbing light to emit light. For the exclusive production of auto-glow range of photoluminescent signages, dedicated production lines are established with the ideal interface of man, machine, and quality processes. Quality-checked rolls are laminated firmly with base materials such as flexile sheets, rigid sheets, or aluminium as per requirement. The laminated sheets undergo automatic laser cutting. Indigenous racks are developed for accurate printing, followed by efficient drying. These photoluminescent signs serve exigency purposes, help disaster management, provide emergency escape signs and exit lights, as well as evacuation exit directions. Our warehouse stocks a large inventory of products for meeting any of the urgent requirements of customers. Apart from the widest range of emergency lights and signages, ProLight Autoglow specializes in designing, developing, and manufacturing customized emergency lighting solutions. Our path-breaking developments include portable, rechargeable, remote area lights in multiple sizes and luminance ranges, floodlights, tower lights, and telescopic tower light for rescue and search operations.
These telescopic tower lights are more than 1 square kilometer range. And this is the world's longest emergency lighting. It's a 12 feet long emergency light.
Wayfinding lighting, products and signages to brighten the path during power outages. Specially designed floor-embedded direction lights are developed for metro stations, warehouses, and underground facilities. Some of our recent prestigious projects include the new Parliament Complex, Mumbai's undersea tunnel of the Coastal Road, Mumbai's underground metro line, the Taj Group of hotels and resorts across India, prominent hospitals, several banks, IT parks, airports, and the colossal Statue of Unity in Gujarat. ProLight Autoglow is driven by a visionary leadership with a deep-rooted commitment to continuous innovations, quality manufacturing, efficient customer service, and empowering the community, thereby contributing to the safety and security of people and the planet for a brighter tomorrow.
Thank you very much. And I forgot to mention, we also do braille signs, especially for the railways and the airports and other places. And I'm also a contributor. We have come up with a national lighting code in India, which is a 974-page document. Okay, so it talks about adverse lighting and light pollution and everything. Thank you very much.
Thank you, sir. Now I'll call upon Mr. Hari Kumar.
It is loaded here. Good afternoon. Just waiting for the presentation to load. My name is Hari Kumar. I work for an organization called Geohazards International. We work on disaster risk reduction, and we do work a lot on difficult terrains. I mean, that is the subject of our intervention today. And what I wanted to talk about was our work with some hill cities. You want me to run it from a pen drive? Or? Thank you. So, yeah, I work for Geohazards International, and yeah, as you can see here, we like to work before disasters happen. We like to be involved in the preparedness and the mitigation part of it. So that is where we work on. And when we talk about construction in difficult terrains, I think hilly areas, like our chairperson said, hilly areas are among the most difficult terrains for construction. And these places have several hazards associated with them. And mostly, definitely landslides, earthquakes, rock falls, debris flow. We have seen debris flows recently in Uttarakhand, and before that even in Kerala. So those are affected with the hilly terrains, cloudbursts. And climate change is making these hazards more frequent, more intense. And I don't think our mitigation efforts have started, keeping pace with the way the climate is changing. The hazards are on us. And tourism and employment potential is drawing more and more people to hill towns. I was sitting next to our friend from Shillong, who said that the population of Shillong has multiplied several times in the last 10 years. And this means we are urbanizing, and we are building onto more and more fragile slopes. These were our hill towns. And the last census we have done, the data we have is from 2011. And in 2011, Shimla was only 1.69 lakh people. Shillong was 1.43. Aizawl, the capital of Mizoram, was 2.91. And in those days, the hilly areas were not uniformly in one seismic zone. Now, most of the cities, including Shimla, have got a double promotion. Shimla used to be in zone 4, and now they are in zone 6. But we still don't have the figures of population. We cannot design tomorrow's infrastructure with yesterday's data. We need data. And that is something we are lacking when we are thinking about future. In the previous session, there was a lot of discussion about designing for the future. And we really need to understand our exposure, our risk, our vulnerabilities well before we can design for the future. So Shimla, which just got a double promotion, looks very good, which means also that a lot of tourists come in, which creates a lot of employment, which creates a lot of population increase. And you think Shimla is bad, then I think we should look for some other cities. Let us see Aizawl, the capital of Mizoram. Aizawl is pretty far away from here, even beyond Bangladesh, hanging on to the rest of the country. And this is a ridge-top city, which means that it is on top of a hill, which has its own hazards when dealing with earthquakes, because ridge-top effects are really, the shaking can be intensified on the ridge tops. And look at the buildings there. You can see Aizawl. no inch of space is left in these hillsides. They have built, through, if it is empty, that means that cliff is vertical. Even if it is 70 degrees, they have built on it. And that is the way we are constructing. And you look further into that, none of these buildings are single-story dwellings or double-story dwellings. You can count them, they are more than 8 stories, 8 to 12 stories high, hanging on to slopes which are really, really vulnerable. And this is the way they are constructing. You see, this is, if I have a plot of land and I am constructing my house, you can see I have cut into the foundation of the previous, the house above. You can see the foundation of the house above is lying on at the bottom of the screen. You can see. And the person above, who stays above, has no problem with this because he himself has cut the foundation of the house above him. This is standard practice. Finally, you do some band-aid kind of solution and nobody will know anything about it till the next earthquake. The earthquake will know these comorbidities. There are comorbidities in our hill towns. And so this is how our hill towns are growing. And our work in Aizawl has been to develop the scenario of Aizawl, an earthquake scenario of Aizawl. What would happen to the city of Aizawl if a 7 magnitude earthquake struck, not even directly in Aizawl, but 70 kilometers away? What will be the effects on the roads connecting Aizawl? Aizawl is not well connected to the rest of the country. Aizawl has 2 roads, 2 highways connecting it, one to Manipur, one to Assam. If these 2 highways are gone, your connection with the rest of the country, the rest of the world is gone. Shimla is similar. Our hill towns don't have very good connections. Gangtok, 1 road. And if there is an earthquake and the landslide is triggered, then that road is gone as well. We have to think about the difficulties in living in these terrains as well. So the effects of Aizawl earthquake, we assess the roads, we assess the power systems, we assess the water supply. Water supply to Aizawl, like Shimla, is 100% pumped from the river. There is 0% water from gravity, which means if electricity fails in the earthquake, your water supply is gone too. Shimla is similar. Shimla is worse than Aizawl in the sense Aizawl has generators which can pump water. Shimla has no generators. If water supply fails, power supply fails, your water supply is gone too. So Aizawl, seismic zone 6. The entire hilly area is now in seismic zone 6. And intensity is very, very high. About 10 can happen according to our code. But in this earthquake, we have only considered 7 and 8 intensity of shaking. And that also, what did we find? We found that the earthquake, if it happens during the day, will trigger 1100 landslides within the city area. 1100 landslides at the same time triggered by the earthquake shaking in one city. If there is 1 landslide or 2 or 3, maybe they will be able to manage. But think about, and even this 1100 is during dry season. That was the estimate of the study. Power grid fails because of landslide is affecting many towers. Water supply fails basically because the power fails, and also that 8-kilometer pipeline is passing through 3 active landslides. The internal roads are cut off by landslides. The health facilities, the main Aizawl Civil Hospital is on a landslide. Partially it will go, and the access to the hospital is also triggered off by a landslide. Communication has failed as well. You imagine this kind of a scenario in a city where about 4 lakh people are living. No water, no electricity, no hospitals, no way for rescue to reach. There is an airport which is 35 kilometers away. The road connecting the airport is landslide prone, and it had a bridge, a very bad bridge, which according to the experts was likely to fall in an earthquake. This study was done 10 years back. That bridge has fallen twice without an earthquake, already fallen without an earthquake. So you can imagine what will happen if there is an earthquake. But this study also gave recommendations for each sector. Looking at the power sector, this is what you need to do to be resilient, water supply. They now have done a lot of work on the water supply. They have an alternate line. Part of the supply is now from gravity. So we'll see what they did. Aisol's landslide risk reduction action in the last 10 years they have now a landslide policy committee. They brought together the engineers, the architects, the geologists, everyone, the decision makers to come together. Normally, the engineers don't talk to the architects don't talk to the doctors, and nobody talks to the geologists. You know, there are silos in which we operate. In disaster management, there cannot be silos. So we have to work together. So they brought them all together in this landslide policy committee. They developed a roadmap for 30-year roadmap to reduce landslide risk. They developed a landslide hazard zonation map of 1:5,000 scale, sir. Normally in any city, what we have is 1:50,000 scale. I'm sure Shillong is the same. 1:50,000 scale maps are useless for any kind of risk reduction. You can see your whole city is in one color, either it is red or orange or green. You really cannot. So what they did further, I have 2 minutes? 2 minutes, yes sir. This is the first municipal corporation to appoint geologists. You see, we have geologists, we have cities which are on hills and slopes. There are engineers. They don't have the service of geologists. None of the municipalities in India on the slopes have geologists. So Aizol empaneled geologists, 90 geologists and geotech engineers, and they banned cutting. Cutting is what is creating the landslides. So made a ban of on cutting during the monsoons, which really reduced the deaths of landslide till cyclone Rimal hit. Till then, they had completely avoided any deaths from landslides. And this is the new regulation which prevents cutting by normal people without a geologist coming on board and examining them. They have new regulation, risk reduction through regulations, and it gives conditions for cutting and requirement for all application. Even the government of Mizoram cannot cut without getting a permit, except, sir, the Ministry of Defense is exempt, except that no other agency can cut without a geologist examining. That is the level of detail they went into, and that is how they reduce risk. And Aizol is just one example. They did not eliminate landslides, they reduced the vulnerability, they invested in knowledge, they empaneled geologists, they also involved in a lot of awareness generation. You can have good regulations, but if people don't follow them, people don't understand why it is required, then nobody follows. So they were trying to build a culture of safety. And as I have written here, culture beats policy anytime. You can have very good regulations, but if people don't have the culture of safety, they will not follow. And hill towns are engineering challenges, and they need geotechnical support as well. Let us know the risk. Let us understand the risk to reduce risk. What can we do to reduce risk without understanding it well? So that is one step the other hill towns should do, and avoid conflicts with nature. We are actually, you can see in the Dharali event in Uttarakhand and several other events, we have been at conflict with nature. That is not going to help. So let us increase our regulations, our control, and build with nature rather than against nature. They say the best fights are the ones we avoid. Don't fight with nature. And who said this? Somebody who knows a little bit about fighting. This is Jackie Chan's words. The best fights are the ones we avoid, and let us not fight with nature. Thank you so much. Let us stay connected. Thanks a lot. Bye. Thanks, sir.
Thank you very much, Hari sir. It was a very knowledgeable topic which we all miss out. Now I request Mr. Jamed to give a talk on the building design.
Good evening to everyone seated here. Uh, I'd like to talk, I've not prepared any formal presentation as such, but I'd like to talk out of a general field experience in engineering that we proposed in states in Meghalaya and similar states having this similar terrain. The subject that has been given here is relevant to the terrain that we proposed the smart city projects in Shillong. In such regions, merely which is blessed with natural beauty, construction is not an engineering activity, but it needs more resilience planning with respect for nature. The first thing to understand this on the scope is to understand the challenge. Meghalaya being one of the wettest seasons, the wettest placed on earth. This area, we need to oversee a geotechnical experience based on all realms. The hilly terrain, the fragile geology, with the foundation work and transportation of materials, which is a hindrance to our construction process. Connectivity itself also becomes a logistical challenge, especially in remote areas. And what we have been doing is that we learn from nature. We have the living root bridges. These one of the remarkable examples of climate adaptive construction. These bridges have been sustained for generations, and the local communities have guided the roots of rubber fig trees across streams to form natural bridges. These bridges grow stronger with time, withstand heavy rainfall and floods, require minimal maintenance, blend perfectly with the ecosystem. Now, the other point that we also need to learn from nature, conceding to it, is the impact on infrastructural projects. Now, with the MIT program, which is running now 5 years, we have road construction, which is visible, and which is also a challenge. In many parts of Meghalaya, roads must be designed with proper slope stabilization. Advanced drainage system, you'd find in Shillong, though it's small, we have a space allocation problem. Every 8 to 9 feet or a 5-meter road has drains on both sides. A meter in width, a meter and a half in depth. We do that because why? We actually decrease the vulnerability, like our former speaker says, not to control landslide, but to decrease the vulnerability. The other thing is that with the use of advanced drainage systems and retaining walls, even a newly built road can deteriorate with one following season of the monsoon. Similarly, so building construction, what we do, we do special foundation designs, the designs that are used widely in the plain areas. We're opposed to that. Mostly micro, deep piling, and the examples of these I'd give to you is a practical, engineered-oriented overview of construction techniques that we used, which is widely used in regions of high altitude and falling within the 5 seismic zone. First is the foundation and structural systems. Here, for every public necessitated building, for every government or private G+3, G+5 or high-rise building, you'd find a team which is fully specialized into geotechnical engineering. Understanding the soil type, understanding the safe bearing capacity of the soil, its lateral pushed, what would be the weight and the pressure load of elements being used on that. That's a very integral part of engineering and construction in the hilly terrains. What we do there is that we have small diameter, high capacity drilled micro grouted piles that are widely used see, for every building, the loads that it carry, be it live or dead loads, it actually transfers into the foundation, which is important. For that, these transfer of loads are competent, which goes deeply into the soil and the rock strata. Apart from the micropiles, we have caissons and rock anchors, which is vertically drilled, keyed into a bedrock, tied back with a stable ground to counteract overturning and the lateral push of the soil. The second is base isolation and damping systems. Wherever people have, wherever in the plain areas you make combined footings, there we have stepped isolated footings. This happens if wherever there is a small scale tremor or an earthquake, it actually disintegrates the building with the foundation, creating a minor shake. Third is the slope stabilization technique. You'd find if you come all the way from Guwahati coming towards Shillong, you'll find roads, and on the sides you'll landslide. On that sloping area, you'd find soil nailing. Soil nailing is a process in which you nail steel from the bedrock, from the sand material on the outer surface up to the bedrock, and there is a mesh pile on top. That prevents landslides. It stabilizes. We don't have to cut a full slope for actually working on the road project. Second is the anchor and rock bolts. They provide lateral support deeper into the hill, especially useful for rocky slopes and large excavations. Third, the cellular confinement system, the geocells. Geocelling actually is important for polymeric cells filled with soil and aggregate to improve the stability of soil, wherein there is an occurrence of falling of soil or of landslides. Third, in terms of excavation geometry, what we use is that we do benching and terracing. Instead of cutting a large earth for the excavation, we have a terrace benched. We create terraced structural assembly of buildings, driving stresses to reduce and facilitate safe construction. The other point, the fourth point, is drainage and water management. Drainage and water management is one of the biggest causes. Water is one of the biggest causes of slope failure. An effective drainage is actually essential. We can see, look at, don't mind me for saying this. If you look at the city of Gurgaon, there are larger roads, but you'd find smaller drains for the roads. If you go back to Shillong, you'd see a lane road of 2 to 3 meters road width. You'd find drains on each side. And this is important because why a small surface drainage catch water drains on the hillside, side ditches and cross drains. It diverts the surface runoff of water, which protect the carriageways of roads. Then, wherever we have a retaining wall, a gravity retaining wall, or a cantilever wall, what we do is that we make subsurface drainage. We have perforated pipes installed into slopes to relieve pore water and water pressure that can actually trigger landslides or maybe collapse of the road. Next, what we do is we have check dams and contour drains. In gullies and channels, small check dams slow the runoff and trap sediment and protect slope toes. Lastly is the seismic responsive building design. Special detailings we have. Reinforced concrete steel, high ductility in steel are being used there. If we're using 550 here, 400 to 500, there we're using 550 and above. High ductile MS plates are being used. smaller footprints and step backs, terraced buildings with a garden, and the other material which we are introducing with fabrication into our latest projects are prefabricated modular systems, like prefabricated slabs, system designed for seismic loads, interlocking fabricated panels, and the India's GHTC housing tech. Third, the sixth point. The sixth point is green and bioengineering measures. If you'd go to the hilly areas on the outskirts of Shillong, you'll find for every far ratio of houses being built, you'd find a small garden equivalent to the ratio of the built-up area. You'd find a two-story building of 1,500 square feet, a larger garden. The garden is there with a proposal for every, which is a traditional way of life of every people living there, that the garden retains the soil, holds the laterite pressure, and actually eliminates the possibility of a landslide. Lastly, my proposal for contribution towards a technology that we are taking out from other states is that we would require heavy machinery and technologies adapted for hilly terrain, which includes drills and breakers, remote controlled shotcrete sprayers. These are important because why we have small roads which is running parallel, roads that cannot have a space allocation for widening the lanes. And better GPS and droning mapping systems for terrain analysis, which would progress or monitoring on slope movement and tracking. And so for this, my takeaways are the aspect techniques. Slope safety is soil nails, anchors, rock balls, geocelling, and perforated retaining walls, cantilever. Then water control, catch drains, horizontal surface drains, check dams, and for building seismic design, which is important, deep foundations, modular systems, and with the help of environment responsive systems, bioengineering, vegetation, and erosion control. These are things that we actually capitalized on worked when thinking of a construction project in these hilly regions which falls under the fifth seismic zone. Thank you.
Thank you. Thank you for giving us insight on the Shillong. Now I request Mr. Dipanshu Garg.
ये लगा दूंगा. The voice is little less here, na? Okay, it's good. Hello everyone. So my name is Dipanshu Garg. I am the last minute entry in this session. So my topic is not directly linked with the topic which we are talking about, but I'll try to make a connect for all of us to keep it interested. Nothing fancy in my presentation, but it's all technical. And my focus is going to be on the existing pipeline, which is already being laid in the urban settings. When I say the pipelines, it means the water, the wastewater, the drainage system, oil and gas as well. So in this presentation, I'm just trying to give very quickly the options which are available throughout the globe for the strengthening of the existing pipelines by increasing the life by minimum 50 years, if not more. Before we start, just a very quick overview about our company. So we are an EPC agency. We deal solely in the trenchless field, which means we work underground the earth. We don't excavate, we don't dig, we do the underground works only for installation of new pipelines and strengthening of the existing pipelines. Then we are among the governing member of the INDST, on whose behalf I am here today. They are the knowledge partner in this organization event. So, to start with the problem, once we understand the problem, then we can have a solution. So, this is how our typical existing pipelines look like when they are old aged, or they are damaged, or they are not surveyed properly on time. So, I'm not sure like who have seen these scenarios, but this is quite often in all the municipalities around India and outside India. In India as well, talking about the hilly areas, now the municipalities like in Manipur, in Uttarakhand, in Assam, they all are also facing this issues of the collapsed pipelines, which looks like this. So we have to understand couple of parameters to understand the requirement when and why we need to rehabilitate the existing pipeline, which includes the performance of the pipelines by the hydraulic means and the structural strength of the pipeline. So this is an institute called as the WRC. They are the UK based institute. They have published a manual by the name of SRM, in which they have identified the ideal pipeline, what it should look like, and what are the damages it can occur, and at what stage we should do the repair. This is the graph from the same SRM manual. So usually in India, the pipelines which are already laid by Britishers, they are almost all have reached the grade of above 4, which means they are almost in a stage of collapsing. So the municipalities which are very much aware of this situation, they already have got the jobs out, they did the expression of interest with all the agencies around the globe, and they are actually working on it, which includes the municipalities of Mumbai, Ahmedabad, Delhi, Kolkata, and all the big municipalities. Among the small ones, the Manipur has started the rehabilitation of pipeline recently, and I am hoping like more and more municipalities will see the requirement of strengthening the existing pipelines. So when we do the design of the existing pipelines, we need to understand, do we need a full repair or we need the local repair? So usually we all go for the standalone, like the additional pipeline which we're going to insert inside the existing pipeline, that should be able to take all the load. The loads include the earth load, the water load, and the traffic load. So how, just to give a pause over here, just to give all of them idea. So we are only installing a new liner, a new pipe inside the existing pipe. So the new liner, which we call it, it is designed to take all the loads which is applicable on the pipe. And the additional liner, it's designed for in such a way that it is there for next 50 years, if not more. The additional liner should be able to improve the existing pipeline flow. So these images are the actual images where we see the joints are open, there is a seepage, infiltration and expansion from the pipeline, which is not visible to the normal public, but we are only able to see it when everything get all collapsed. So if I may say, just an analogy, we are working like a blood stream in our body. We are inside the body, we are not visible outside until unless it is all collapsed and damaged. So it's like a prevention method as well, to ensure there is no visible damage to the outside body. So we have to make sure whatever the pipeline we are installing inside the host pipe, it is able to improve the workflow and sustain all the loads. This is a typical job site looks like in an urban setting, which can be matched with the hilly areas as well. We can see the loss of traffic is there, we can see the pipeline are getting all collapsed and all. So when we say we come as a trenchless partner,
we meant we don't open cut, we don't excavate the pipeline. We access from the existing manholes or the chambers we call it. Then from those chambers only we insert the new liner. Very quickly, you're trying to sum it up. So these are the typical standalone lining systems which are available around the globe, among which the number one is called the GRP, the glass reinforced lining. So this is the pipe which is made up of the glass fiber and resin and sand. So the glass have a capability of sustaining load more than 500 times as that of the concrete pipe. So we manufacture the pipe, not me as in the industry partners, they manufacture the pipe as per the requirement of the host pipe, and we install the pipeline from the existing chambers. So what we usually see that the existing pipeline, be it the water or the wastewater, we have to make sure that the pipe is in circular or the non-circular shape, is the water is flowing or not flowing inside the system while we are doing the repair. So based on multiple parameters, we can pick and choose the option which are available in the market. The next is called as the CIPP, cured in place pipe. It comes in a fold form from the factory. Then we insert it inside the host pipe, and we have two ways of curing it. The number one is the thermal curing, in which we insert the liner, then we pass on the hot water or the steam to make it strengthen, to make it cure and take the shape of the host pipe. The other way is the curing by the UV rays. So we simply use the UV train, we insert the train inside the host, the liner pipe, and we cure it. So again, it's little more of a technical side, but understand it in a way that it's like a paper form or a folded sheet. We pull inside the host pipe, we give the air to make the shape of the host pipe, and then we make it strengthened by the UV light. The next way is the MWSL, machine wound spiral lining. Over here we use the PVC material. It is not a glass, it is a PVC joined with the steel, the stainless steel. We do the winding as we see in the below image inside the host pipe. Quickly, the next option is the FFPP, which is called the fold and form pipe. It is typically used in case of the water pipeline, where we have to ensure the liner is safe for the drinkable water as well. The last among the most of the options is the geopolymer lining. This is among the new methodologies we have opted in India right now, in which we spray a specialized cementitious material in the host pipe. This is not the spray lining as it is. This is an independent material called a geopolymer, which is again designed to take all the load by itself. Just on the end of the presentation leagues, so this is how a typical project looks like. So this one is from the Kolkata. The pipeline were laid by the Britishers around 160 years old. The shape was 1800 by 2040 mm, which is a big shape. A car can go inside the pipeline. It was that big. So we did the rehabilitation using the GRP method. On the on top right, we can see the manufacturing plant of the GRP, because it's a non-circular, so there is no plant in India manufacturing the non-circular pipes, so we made it our own pipes. And at the center, we can see a graph where we can see how the hydraulic performance is improved after installing the new pipe. These are among very other projects using all the methodologies which we have been doing in India and outside India, including the CIPP and MWC geopolymer for all diameters ranging from 150 mm to 5000 mm. Lastly, this is like a graph which we it's like a chart which we made it on our own. So it helps a layman terms to specify what is the existing pipeline condition. Is it a gravity pipe or a pressure pipe? What is the diameter? And based on all the parameters, we can pick and choose the methodologies applicable on the same. And this is the last slide of my presentation. over here, I'm just trying to explain about the institute by the name of INDST, Indian Society for Transit Technology. They are the independent agency who actually promote such methodologies. So if in case any municipalities, any of the potential owner of the pipelines, they want to understand even better about the methodologies available in India and outside India, please approach them. They have a show as well in the end of this year. So we would be happy to have you there as well. Okay, thank you so much.
Okay, thank you, Dipanshu. Okay, ladies and gentlemen, with this we come to the end of our session. Just to recapitulate what all has happened, Mr. Harsha has given a talk about the lighting and the aspect of it. Mr. Hari has given about geohazard, which basically earthquake specific to hill terrains of Aizawl, Shimla and other examples. And he talked about the policies committee and the safety aspect, the culture of safety. Knowing the risk is the most important aspect of that. Then Mr. Jeremiah talked about the Shillong in detail. And lastly, Mr. Dipanshu talked about the water, which in fact is a very new thing which came to us. And now I open the forum for questions, if anyone want to ask anything.
I am Lokesh Sharma, I am an architect. Initially, Colonel Brigadier Sahab, you spoke about working in these high altitudes, about the infrastructure that Army is building. Can you throw some lights about how these buildings are being made usable in terms of heating or temperature control?
Yeah, we have the thermal insulation. In fact, it's a very pertinent question I have not covered in my topic, in my part. Thermal insulation is one of the most important aspect. The temperature outside goes down to minus 20, 25. I'm talking about Leh, and in forward areas up to minus 50. But inside it has to be livable up to say between 10 to 20 degrees. Central heating systems are the one which are now being incorporated. The walls are made with insulation. The heating system has been put even in the layers, which is the water oblique solution goes over it. And these are the present method which are being undertaken, already under construction. Now the heating system is driven either by a oil-fired generator, oil-fired heater, or it is electric-fired heater, or it's a solar heater. What we have been using till the time electricity was not there, it was the oil-fired heaters which were being used. Presently, wherever the electricity has come, we are converting to electric-fired, and as a future, the solar generated heating system is also being undertaken. I hope that answers the question.
So what about glacial areas where do you have prefab structures, or even still we are in tents or such
No,
kind of?
this is a very pertinent question. Indian Army, when I was lieutenant, that time we used to stay in tents. But nowadays that is not what Indian Army is looking for. All our training areas, forward areas, we are making minimum prefabricated structures, panels, puff panels, iron wool panels, and we are looking for permanent accommodation, because when our troop sees the adversary across, he is living in a 5-star building and our boys are living here, coming on a road which is a kacha track and going. So that is not acceptable. In fact, a lot of changes have happened. I must extend invitation to all the corporate world and the industry to come and visit Leh. It has seen a very sea change has happened, and now we are looking for even further new development, both in terms of structure, whether it is a insulated structures, though it's a fast constructed panels are there, but now even that structure doesn't give, in the Leh region that will not function. That can function in say Punjab or Rajasthan, but in that area even those structure fails. Now we want heated, centralized heated system which are required to be undertaken there.
So, what about glacier areas also? You have prefab structures now?
Yeah.
The Siachen glacier.
Matlab,
right?
if you say per se on the top of the glacier, say Bana Post and all those, naturally that cannot happen.
cannot happen.
But if you are talking about the base camp, Siachen base camp electricity connection will be there by September.
Oh, great.
The electricity line actually is already laid. It will be electrified and it will be functional.
Right.
So we are now looking for permanent structure even at the base camp.
Right now. So, but especially in the slopes, now when because some of the areas there will be permafrost kind of a thing. So, surface you may not
Yeah.
find snow, but
The
below the surface there will be. If you are
perma-
putting a prefab, again there should be a foundation for it, right?
Yeah.
So, does that have an impact? Because if the permafrost melts,
Yeah.
there is this thawing will be there. So,
Permafrost is a challenge. In fact, on the DBO axis, you find a bridge which has been made now by the border roads, and that bridge has been made in the permafrost. The permafrost is a very typical. It is a basically ice below the surface. On top you cannot see, but it freezes below. So there are technologies now available, and we have been constructing. Though MES has not reached at that level, we are not going that deep. But in future, all our ammunition storages which are underground, they will happen in those areas, and we have to look for those designs.
okay, great, sir. Right. We already have this China Beijing Lhasa line, which is running through the permafrost areas. Right?
Yeah,
So
exactly. Their railway lines are being
Yes.
the railway lines are being made in that area.
That area, right?
But I must tell you, we are not very far behind. We have also catching up in
Catching up
those
fast.
areas.
So just one question to Divanshu Gargi. Right, so you talked about inserting a new pipe into the existing one, right? So what happens to the capacity then? Doesn't that capacity get reduced, and doesn't that lead to clogging of the system?
That's very interesting question you asked me. So the new pipeline which we are installing it, they are designed in a way to increase the flow capacity by minimum 35%, if not more. So because of the reason, it is less of the friction is very less in case of the fiber which we use. And that is the one point. And the other point is the area reduction of the host pipe is hardly 8 to 10%. So considering both the parameters, the area reduction is only 10%, but are increasing, the capacity is increased by minimum 40%, if not more.
Now, most of the time what we see is that while construction, you showed from some photographs of collapse and all, right? While construction and laying pipes, they don't use a
Bedding.
any foundation.
There is no
material or
bedding.
Backing is not done.
Correct.
So should it be done so that such kind of incidents can be less, and then pipes should be laid?
So
Or
it
is
can
there a
be
technology for that?
absolutely, absolutely. Lots of things can be done, right? So we have to understand in which stage we are. We are talking about the existing pipelines, but the point which you are making is for the upcoming pipelines, right? If we are going to install a new pipeline, then obviously we have to ensure that our bedding is done, our joints are proper, right? But if in case the existing pipeline which are already laid, we cannot open it again.
So can't we do some grouting kind of a stuff or make it strengthen? Just like Leaning Tower of Pisa, we did pull it.
That's
off.
an extreme example. There's an extreme example. But again, we have to understand, we are talking about the urban areas where the traffic is the concern, right? We cannot open cut everywhere. So these options are the one which we can work from the existing chambers only without disrupting the population around the area. And it can strengthen throughout the length, 100 of kilometers, it can do it.
To Hari sir and Mr. Jeremiah, right? So in case there is this situation is that in slopey areas, Kerala and all, what we find is there is piping that results within the soil. The soil piping happens. So constructions on such sites, even you doing that nailing purpose, it doesn't work. So is there any solution for that? Have you thought about such kind of things? Because the soil conditions are somewhat nearly similar to what we have in Kerala and in Meghalaya.
No. Soil piping is not a problem in Meghalaya or anywhere else in the Himalayas. It is specific to the Western Ghat problem.
Western Ghat. No, even
It is,
Himalayas also Meghalaya
Not
also
not soil piping. The kind of soil is different. So not in Meghalaya. And I think Kerala University yourself, Dr. Sajin, has,
Yeah,
and
Sajin,
KSDMA has come out with some solutions for soil piping. But the kind of issues with slopes in the Himalayas is very different because of the nature of the formation of these mountains. One side of the slope can be really high landslide prone, while the other side is hardly landslide prone. So, which is why the importance of having good zonation maps will be very, very important. I think maybe you would like to add.
Himalayas, you are right. Himalayas, there is no. But Meghalaya, we have soil piping, right? Meghalaya region, we do have soil piping related issues, right?
He has not even heard about it.
It's not there. Okay, it's not there then. Okay.
It's hardly soil, it's rock.
Something I liked that you suggested was to have geologists in a city planning positions. That is something a takeaway from this particular thing. Right. So let me conclude this. So do you want to make a concluding statement, or shall we conclude it?
Okay, thank you, gentlemen. It was a very learning experience, listening not only in this session, the earlier session which we have heard, and the topic which we have covered here, though it is prelim in nature, we need much more such kind of discussion to happen. And I'm very happy that industry and the Municipalika, and these are the good steps in the right direction, and I am very sure that these steps will take our national security to the next level by the way of construction, by the way of risk management, which is again a topic which is generally overlooked. And from all the panelists, I thank you all. Thanks.
Yeah, thank you. Now let me request Brigadier Randeep Chauhanji to present mementos to fellow panelists. Mr. Jeremiah Dykes. Dipanshu Garg. It's a photo. Hari Kumar ji. For Mr. Harsh Joshi, the memento will be collected by Garmanpreet Singh. And let me take the honor of presenting the memento to Brigadier Saab.